We're going to continue our discussion on proportions in chapter 7.3 with our discussion of similar triangles. Now let's remind ourselves of exactly what similar means. And we'll do it in the scope of triangles. This could also be said of just plain polygons. Similar triangles, or polygons, either one, are triangles with congruent corresponding angles and proportional corresponding sides. So remember, we've got to go back and look at the corresponding angles and the corresponding sides. And remind yourself of exactly how to do that so that you're looking at the correct corresponding angles and sides. Similar triangles, remember they have to have congruent corresponding angles and proportional corresponding sides. Now there's three ways that we can immediately tell whether or not two triangles are similar. Okay, simply by looking at their angles and their sides. This is sort of like congruency. We went over and we talked about congruency. We had certain things like side, side, side congruency, side, angle, side congruency, angle, side, angle congruency, and so forth. This is the same way. By looking at the angles of two different triangles, we can immediately determine whether or not those two triangles are similar. First one is we're going to look at is called angle-angle similarity. Angle-angle, or AA similarity. Angle-angle similarity, that means that two angles of one triangle are congruent to two angles of another triangle. Well, what does that mean? If we know two angles of a triangle, can we find the third? Yes. Okay? So we know all three angles. So if two angles of one triangle excuse me, are congruent to two angles of another triangle, then that third angle also has to be congruent. Now, similarity is about congruent corresponding angles and proportional corresponding sides. Well, if all three of the angles are congruent, then the only thing that's different about those two triangles is their size. One's bigger, one's smaller, or they may happen to be the same size. Okay? What determines? That means their shape is the same. What determines their shape? Their angles. What determines their size? S-I-Z-E, it's their size. Sides. S-I-D-E is what determines their S-I-Z-E, or their size. Okay? So if all of their angles are congruent, we know they have the same shape. Therefore, with angle-angle similarity, we know that two of the angles are congruent to two of the other angles in the other triangle. Therefore, all three angles have to be congruent. Therefore, those two triangles are similar. Now, we can take the same thing with side, side, side similarity. The measures of corresponding sides of two triangles are proportional. Okay? The measures of corresponding sides of two triangles are proportional. Side, side, side. Excuse me. That means all three sides of one triangle are proportional to the corresponding sides of another triangle. Got to get that corresponding sides in there. Okay? If that's true, that simply means that the triangles are the same shape. They simply have different size. One's smaller, one's larger. They're proportional to each other. Okay? Side, side, side similarity. Now, we have one more. It's called side, angle, side similarity. Works very similar to side, angle, side congruency in that we have two sides and the included angle. Remember, this angle has to be the included angle. Side, angle, side similarity. The measures of two sides of one triangle are proportional to the measures of the two corresponding sides of another triangle, and the included angles of both are congruent. Okay? So what we have is we have have two sides that are proportional, the angle between those two sides are congruent. All right? The angle between those two sides are congruent. Those are three cases for similar triangles that we're going to do some samples on. I'll show you what we're talking about. Angle-angle similarity. Two angles of one triangle are congruent to two angles of another triangle. Side-side-side similarity. The measures of corresponding sides of two triangles are proportional. Side-angle-side similarity. The measures of two sides of one triangle are proportional to the measures of the two corresponding sides of another triangle, and the included angles are congruent. Remember down here on SAS, this angle must be the included angle. Okay? Let's look at some samples.